Question 9. We're going to do a method of sections problem here for a kind of bridge looking framework. And I'm interested to find what the internal forces are for BC, EC and EF. I'm going to cut my framework in half, and then I'm going to expose my internal forces, and then I'm going to resolve the forces and resolve the moment, and then find what BC, EF and EC and EF is. So if you want to do the whole problem in one go, then pause the video now. Otherwise, I'll talk you through solving each individual force and suggest where you pause the video in that case. First thing, you need to decide what's the order you're going to be solving these things in. So the first one you notice is that EC is the only one pointing upwards. It therefore makes solve that force first. So that's the only one pointing upwards. Resolving forces a bit easier to do than taking moments. So taking moments would be the next thing to do. Notice here we've got two unknowns coming from this point here, which is E. So taking moments about E is the next logical step. And then finally, since we're looking for all three forces, to apply our third equation to find what the third unknown is. So let's start off with trying to find what EC is. You want to pause the video and notice that we've got 4 along the bottom, slightly displaced there, 4 along the bottom and 3 up here for the framework. So sine theta is going to be opposite 3 divided by hypotenuse 5. Sine theta is 3 over 5. Going to sum up in the y direction. And so the first one we're going to have is EC times sine theta to make it point upwards. It's not swinging through its own angle. What else can I see pointing upwards? Well, I've got the 3.33 pointing downwards, so that would be a minus 3.33. That equals 0. Let's rearrange that, and we're going to get EC equals 3.33 divided by the sine theta. But sine theta I know is from here is 3 over 5. So put that in your calculator and you're going to find that the solution is 5.55. Next, we want to take moments. But the question is where. Well, we found the EC force, so the next thing we want to find is either BC or EF. Makes little sense taking moments at B and introducing two unknowns EC and EF. Makes even less sense taking moments at A and introducing 3 unknowns, although previously I found one. However, I take moments at E, that sounds kind of sensible because then I'm going to get rid of those 2 unknowns because moment is force times distance, so those 2 unknowns will go. So pause the video and see if you can work out the solution. So take moments about E. Notice that the 80 goes straight through E, it doesn't create a moment, so get rid of that. So we take moments and we see that the BC force from here to here is going to be 3 meters. It's going in a clockwise sense. From here to here is going to be a negative 3.33, and that would be a distance of 4. Nothing else there, so let's rearrange that. So we've got 3.33 times by 4 divided by 3. And that should give you 4.44 kilonewtons. Okay, now last one, we've found BC, we found EC, so we're now looking for EF. So make a note of our previous results, pause the video and see if you can work out what EF is going to be. So the first thing you want to do is examine the triangle, the angle, the EC angle is going up, and it's going to be such that we've got 3 opposite, 4 adjacent. So I'm going to resolve all my forces in the x direction. So that means that my AT here is pointing not in the x direction but the other way, so it will be a minus AT. I can see BC is pointing in the x direction. I can see that EC will point in the x direction if I swing through cos theta, if I swing through theta here. So I'm going to have EC times by cos theta. And my EF doesn't really, does it? So EF is pointing in the in the x direction. Okay, so that's my equation. That's what we're looking for. Substitute in your previous results. So BC, you're going to have 4.44. EC, you're going to have 5.55. Rearrange it. Interestingly enough, we're going to get these two answers being the same. Minus 4.44, minus 4.44. Rearrange that, and you're going to get a tension of EF is going to be a tension of 71.12.